we come to the normal distribution analysis. This is very interesting. Okay, because normal distributions now is become one of the crucial part of your analysis in most of the statistical analysis. Okay, so later when you go for real analysis and real life experiment, you will consider the normal distributions analysis in order to find the solution for, or in order to find that probability or outcomes of that experiments. Okay, and this is very, very useful as well, because when you go for like high level of analysis, problems or experiment or research, so you had to, normal distribution is one of the component you have to consider in order to get a better analysis or better output for your research. Okay, because the normal distribution is deemed to be as accurate solutions, and even we can use for the large size samples. Binomial and Poisson is just limited because due to it's a sample size. You cannot take much very small sample size to be considered when it comes to binomial. But normal distributions, you can go up to more than 100. Okay, if the data is even bigger, so then you go for the big data analysis, like random forest, support vector machines, bagging, Boruta. Okay, so you can use that the supervised data or supervised analysis. Okay, yeah, so basically this is the things. Okay, let me see the normal distributions. What is that the definitions? The normal distribution is one of the many probability distribution that continuous random variables which is can process. So whenever you look into that, any variables or samples, all right, even your daily life activity, we cannot run away from that the interval oriented samples, which is the measurements like age, okay, height, distance, time oriented. So then we have to consider this normal distribution. The normal distribution is also like most important and most widely used for all probability distributions, as I said earlier. Okay, and remember the property, another property is a normal distributions also is a curve, is bell-shaped curve. That means when you just draw, it look like a bell. Okay, and its mean is denoted by mu. So the mean value denoted by mu, and its standard deviations is denoted by the sigma. Okay, this stuff. Okay, this is a mu and this is a sigma. All right. All right, as you can see that the general density function of the normal distribution is look like this function. But don't worry, you're not going to use this formula. Remember, this is the statisticians when first the analysis made, so they come to this formula. Okay, they call as a probability density function. After when they made this create this type of the formulas, I mean the function, they come to this function, they standardize it when after they introduce the Z distributions. Okay, and at that point of times we start to use that very simplest form of that the normal distribution, and we do have a calculator as well as we have the tables. So in the normal distribution, there is a four property is very, very essential, very, very important to know. Okay, this is your rules you have to follow always. Okay, first the total area under the normal curve is, make sure it is always 1. Okay, second, the curve has to be symmetrical. Okay, and the center is a mean value. Okay, so when it's symmetrical, the center has to be your mean, and then the two tails of the curve extend indefinitely. The mean it just go indefinite values from negative infinity to the infinity. Remember, the tail is closer to that axis, your x-axis, but it's never touch that the x-axis. It never cross at all. Okay, it's come closer to closer, but it's never gonna touch that your x-axis. And then the mean, mode, and the median are all the same. So normal distribution curve, everything the symmetrical, the mean, median, and the mode is deemed to be as a fall in the same pivot line. Okay, as you can see here, this is the normal distribution curve. So remember that the tails here, the two tails from the left and right hand side, it's gonna be like extends to up to infinity, negative infinity to that infinity, and it's never crossed that the x-axis. And the center, it's a always remember this is mean. So when you do calculation, how are you going to understand this, the normal distribution curve? Okay, we have some analysis. Say only the accepted regions, the people will be considered in that research. Say everybody, say they already determine only that, for example, whoever get 90%, 90% marks will be attend an exam, attend for that the higher exam, special exams. Okay, assume that. So there is like a filtering point. So whoever obtain 90 marks and above eligible for to enter that special exam. All right. So now they need to gather. So they cannot take exactly whoever got a 90 marks, you know, to get that. Whoever got a 90, what do you call, those who get a 90 marks in the exam, the first exam, so they should attend the exam. So they need to do some analysis. Whoever closer to that 90%, 90 marks in that first exam. So they will check. So maybe there is some people, they will get like 85, 82, 80. So maybe they fall just next to that, this close to the mean. Say, assume that the mean is 90 marks. So mean is 90. So they will pick the person whoever is closer to 90. So again, maybe there is 95 and is whoever the closer to this point and this point. All right. So they will be chosen, say between this point to this point. So maybe between these 2 points, probably these people between 80 to 100. So they will be chosen to sit for the special exam. So this is how we need to calculate. So it means we calculate the based on the mean. All right. So they choose that acceptance based on the mean values. All right. Always remember when the both side is the 50 and 50%. So it's considered as 0.5 and the other side will be 0.5 so because it's symmetrical. The probability values. Okay. Now we consider the standard deviation. So there is in a research, there is a 1 standard deviations, 2 standard deviations, right? So okay. So this is like what does it mean? Each of the 2 shaded regions is very close to 0. So it means here we call 1 standard deviations here, 2 standard deviations, and 3 standard deviations. So every there is a percentage. We have studied that before. So mu plus 3 standard deviations, that means there will be fall here. So mu plus 2 standard deviation is fall somewhere here. Okay. So based on that, the significant size or the interval. Okay, significant of interval. So you should gather those information. So say if it is your standard deviations is given as 5, so you can see that the curve also will be slightly higher. Okay, if the standard deviation is a 10, it will be slightly lower. So as much the standard deviation is higher, so the stiffness of the curve also will be reduced. Okay, so that is how you need to classify those stuff. Okay. Now, look at here. If the standard deviation is if it is same, but the mean value is a difference, that means it will be shifted. The location will be shift. The first case is actually the mean value is the same. Okay. The first case, the mean value are the same, but only the standard deviation is change, is different. So then how does it look like? If it is make it the standard deviation the same, but the mean is keep changing, then mean it will be shifted the location and the stiffness is still remain the same. Okay. All right. So the standard normals distribution, I think we can continue in the next class. Okay, on Monday. So yeah, so we can stop here today.